Okay, my goal for the last few things that we're going to do before we wrap up the course is to talk about some more advanced communication system techniques, and for you to understand a little bit about what's going on in these next few videos, we need to talk about this idea of signal constellations. All right, so first of all, there are a lot of different modulation schemes that we haven't covered in this class. I wanted to give you an overview of how a communication system would work end to end and all the problems that you needed to solve in terms of carrier synchronization, symbol synchronization, coding, both channel coding and source coding, and what happens with the channel, and all these kind of issues we spent a lot of time talking about. What we didn't have time to do is talk about a lot of different types of modulation schemes. All right, but one important type of modulation scheme gives rise to something called signal constellations. And in general, what we do is we talk about if we want to send a signal, okay, so we could have a signal that's represented by what's often called basis functions, okay? So to make this easier for you to visualize, most of the time the basis functions are going to be cosine and sine. Like V1 is cosine and V2 is sine. This shows up, for example, in Fourier series. What we know from Fourier series is that sine and cosine are orthogonal, which means whenever if I integrate it over one period of cosine omega ct sine omega ct dt, I get 0. Okay. The other thing that this came up with was we looked at quadrature amplitude modulation, and that's certainly a form of this where the two basis functions are cosine and sine. Okay, so starting with that, what I can do then is I can represent a transmitted signal with some amplitude A1 V of t plus another amplitude A2 V1 of t, A2 V2 of t. All right, and if I did that, I could have a diagram that represents the constants. Here's the constants A1 and A2 in what you would call basis function space, or signal space is what some people call it. So along the phi1 axis, I would have an amplitude, okay, amplitude A1. All right, so maybe here's A1. And then on the phi2 axis, I could have A2. All right, so let's say maybe A2 is right here. And so this signal constellation point would be A1, A2. Right, so it looks like a Euclidean space where you just have points in space. But what we really know is these are tracing out functions or waveforms that can be transmitted over a channel. Okay, so like I said, usually phi1 and phi2 are sine and cosine. There's other options out there. Like I said, there's a lot of different modulation schemes. Okay, so let's think about that. If we took this scheme and we expanded our sets of symbols, right, with our 4PAM system, we had symbol values that were -3, -1, 1, and 3. And you get the idea. These are just amplitude values that are spaced apart by some distance d. The distance d has to do with the power constraint. Okay, so this is 4PAM, but we only had a single signal basis function. We only had the cosine part. All right, so if we extended that and we did, all right, let's say these are the amplitude values for phi1 and these are the amplitude values for phi2. So it's just extending our system that we already have. These are the amplitude values that you could use. Well, wouldn't that trace out now? Okay, so I can draw this signal diagram. Okay, if this is phi1, here's phi2. Wouldn't this now trace out a constellation in space that looks like 16 points. Okay, so for example, here's -1, -3, -1, -3, +1, +3. I got that spaced wrong. +1, +3, and so forth and so on. So you get these points that come from demodulation. You know, we demodulate just like we did before, only this time there's both a sine component and a cosine component. And you get this constellation in space, in the signal space. Okay, so as you might expect, you could still send data through a channel like this. Now we're representing, each point represents 4 bits, right? Because let's say I wanted to send -3, -1. Okay, so I go over here, -3, -1, that would be this point. Okay, and because there's 16 individual points, I could represent 4 different bits for each point in the signal space. All right, so that's the idea. If I generalize my 4PAM system, I would start getting soft decisions, and these soft decisions would look like, you know, I'm getting things close to the signal constellation points. And so I'd start seeing, you know, points clustering around. If the system's working well, it's clustering around these constellation values. And as long as I can tell them apart, I can correctly decode the symbols, and from the symbols I can decode the bits. Okay, so that's the idea. This would be a 16-level QAM system. All right, there's different types of systems that you can use. Sometimes you'll see something that's based on simply the phase of a sinusoid. And you can use trig identities to get that the signal constellation is going to look like points spaced along, equally spaced in phase. So it might look something like that. Okay. Oh, I got too many X's. Okay, so 1, 2, 3, 4, 5. I don't have enough X's. What I was trying to do is 8 equally spaced points along the circle. All right, so you can figure out that this would be 8-phase PSK. All right, so I'd have to start over because I didn't get the spacing right. But you get the idea. 360 degrees divided by 8. Put those around the circle. Okay, so now that you have that background, I'm going to post a couple more videos. I just want you to watch those and catch the terms that you're familiar with. You know, I'm hoping that you'll realize that you learn quite a lot about communication systems. You won't understand every detail about these videos that I'm going to post, but it does show you a communication system in action is one of them. One of them is, you know, a video from the authors that shows a communication system in action, and they kick in, you know, clock recovery and carrier synchronization and channel equalization, all those things. The second video is looking at a more advanced technique for like Wi-Fi and mobile communications, where we're looking at sending a lot of data over various channels, and it's kind of a cool video. So you can see why we didn't get that far, because it's got a lot of complex things that show up in it. All right, so take a look at those, and then we'll meet on Monday and talk about the final exam.